Okay, so usually when I come for the conference, I don't make a slides only like a day before because the things are changing so fast. So I usually try to give the latest information so that you are all up to date. So the title is like all you wanted to know but forgot to ask about AI factories. So the first question is, has anyone seen any of the GPU racks from NVIDIA or anyone else? Okay. Who is paying $200 for ChatGPT per month? Okay. I would like to ask you not to make the pictures from the presentation because there is a lot of NDA-related info, so I would like, but I'm going to be very honest and give you all the stories, everything with regards to the AI factories. So, before we start, just to give you some brief introduction. So, I am with NVIDIA since January 24. Before that, I was 11 years with Microsoft, and I have been deploying AI clusters, or actually GPU and HPC clusters for Microsoft since 2017. And actually, I've built the ChatGPT starting in 2018, and you have only met ChatGPT in 2022 when it became commercial. So for NVIDIA, my role is, as American would say, I'm covering the rest of the world. I don't cover US. So responsible for data center readiness. So what that means is that NVIDIA has a reference design for the GPU deployments. So I'm working with different data center providers, VCs, companies who are looking to deploy AI factories. And with the data center readiness, what it means is, in the past, when you had like standard deployments with air-cooled racks, if something goes wrong, there are only two issues. The hardware is bad, you need to replace, or there are problems with the temperature at the data center. For the liquid-cooled deployments, the thing's a little bit more difficult. Basically, if you are trying to deploy something and something goes wrong, you did your validation, benchmarking, the different things could happen. So there are problems with the temperature, there are problems with pressure, CDUs. So basically what we are trying, or what I'm trying to do is when I talk with the people, try to explain end-to-end the process and then decide what needs to be done, how do you want to deploy. This is the only commercial slide which I have. So for the people who do not, let's say, know how NVIDIA is working with AI factories, basically there are three models. There is a model in the middle which is called DGX AI factory. So DGX, that is the product from NVIDIA. So we build the rack and then we would provide to, so let's say if you have a customer like, let's say Roche is the Swiss drug based company who just announced, I think last month, that they're going to deploy a first AI factory. So basically, they will tell us we have, let's say, a data center from Equinix, QTS, whatever, in whatever city they want to deploy. They would like to order NVIDIA AI factory with 8 racks, storage, and basically NVIDIA would also provide the software stack and even help them to adjust their models and run that on the AI factory. And then you have OEM partner-based AI factory. So you have seen, or you will see on LinkedIn, the pictures from Dell, Supermicro, HP. So actually right now there are 13 different companies who are manufacturing the racks. So the companies can go and buy GPUs or NVLink switches from NVIDIA, and then the rest within the rack, they can fill it by themselves. So let's say CoreWeave is using Dell racks. Microsoft is building their own racks. They will only buy the GPU. So and then different companies have different strategies. And then basically you have the data center, what they can choose. They will buy NVIDIA certified systems, including the networking. And then with regards to software, it's completely open. You can buy the software from a third-party company. You can buy the software from NVIDIA. And then the last model is this DGX Cloud AI Factory. So for some of the customers who are looking for quick capacity from NVIDIA, basically we have deployed our own hardware with Azure, Google, Meta, Oracle, with all the hyperscalers, and we have also capacity with neoclouds, Nebius, Nscale, Firmus, and CoreWeave, and some to come. So basically, these customers can come and say, hey, I would like to get whatever, 1,000 GPUs for next 4 weeks. So they can get a virtual capacity within these clusters. So the idea behind it is just to provide a quick capacity, because if someone is really looking for a large capacity for long term, they should go and buy that from some commercial companies instead of from NVIDIA. So basically, this is a kind of like a ecosystem from NVIDIA. So what you see is AWS, CoreWeave, Google, Meta. So these are all the companies where customers can buy the capacity. And then here are the second level is basically the partners from NVIDIA who are manufacturing these racks. So usually, as we say, without the partners, NVIDIA could not exist, because everything what has to do with AI, we are all here together to try to serve the customer. And as I said, we are also leaning a lot to our customers. Okay, so as I told you, I was fortunate to build the ChatGPT, and basically from all the OpenAI clusters from 2018 to 2023. So I just wanted to give you a few lessons learned, because I think yesterday in the panel I was also telling you a little bit about logistics. So the first cluster which was deployed is actually in Iowa, Des Moines, Iowa, in US. So this is the picture. This was the information which was published in Wall Street Journal. They were the first one to say, hey, the cluster is there. I was very proud to, let's say, to what I did, but I never shared the pictures, because if you see the picture, the people would say, hey, like, this data center is empty. That's true, because in the current, let's say, with the current hyperscalers, the data centers which are built are cloud data centers. These are not the data centers where you can deploy AI factories. So in this data center where you have, let's say, average tile of 11 kilowatt, you're trying to deploy, these were the racks of 25, then we tried to deploy 45. Now the racks are 125, 138 kilowatt, and by the end of the year, Vera Rubin is coming, which is 225 kilowatt per rack. So basically, there will be a lot of empty space. The second thing is, let's say for the first cluster, what we deployed, so the picture in the middle is actually for 27 megawatt cluster, we used 102,000 cables. So if you take all these cables together, it's like when you travel with your car from Seattle to Miami, it's like over 5,000 kilometers. It's like 25 trucks, only cables. And then when you have like a company, let's say OpenAI came to Des Moines, how do you explain the technical company, like how big that cluster is? So basically I told them, in this cluster we used 4,400 switches. If you stack them all together, it's an Eiffel Tower. Then I also brought them like a cable, which is 150 meters. And I told them, next time when you call me, do not expect that I'm going to replace that cable within the next 15 minutes, because it takes 4 hours. So the logistics and everything, what is around these clusters is really huge. And then I already told you yesterday a story about insurance, because the cost of the transportations are really huge. So what was very interesting with everything what we did with this, or coming with AI, is basically the amount of data which is available is giving us opportunity to predict and try to build or virtually build what we want physically to realize. So basically, NVIDIA have started in last, I would say like 3 to 4 years, talking about these simulation and digital twins. So the idea was you build something, you test, you improve, and then start maintaining. So like what we did for building our racks, building the servers, we have right now like 13 production lines. So the first production line was built in digital twin. We built it, and then the data which was coming from the production line was coming back into the simulation tool improvement, which we were trying to see like what kind of improvements you can do, and then build the second line, third, fourth, and basically that is this NVIDIA digital twin. So we are now applying that also to the data center. So basically you would be able to build a complete cluster, complete data center without putting any, let's say, physical materials before you can do that. You can do everything virtually. So this is, so if you go on the YouTube, so this is like a small video about digital twin, and because people are saying, hey, this is all virtual, this is how it really looks in the real world. So what you are seeing for let's say, I mean, this was deployment in San Jose with Equinix. So this was the first GB200 AI factory with 8 racks. So what you are seeing is, let's say, when you would have like air-cooled racks, usually it's like only 2 power connections. With these racks, because it's 125 kilowatt, you're moving from 16 or 32 amp to 63, and you have 8 power connections. With the new generation of Vera Rubin, which is coming this year, we are moving from 63 to 100, 125 amp, also with 8 connections. And then, because it's all liquid cooled, actually, the GB200 was like 87% of the rack is liquid cooled, 13% is air. Now with Vera Rubin, we are going to 92% liquid cooled, 8% air cooled. And the idea is to go and start pushing for everything to go to liquid cooled. But what you're seeing are these hoses. These are like a 1 inch. Then we will be moving to 2 inch. And with Vera Rubin Ultra 4 inch, because you need to guarantee 1.5 liter of liquid per kilowatt for the cooling of the cluster. So these were some of the deployments. So as a customer, you can choose: do I want to deploy racks with a raised floor, or is it the liquid cool connections would be above the racks? So the last 3 pictures, this was a deployment in Sweden. So when we had these discussions, because the racks are very expensive, we had a technical discussion with the customer, the lawyer from the customer, the data center, the lawyer from the data center, and NVIDIA. And then we were discussing how these racks are going to be connected. So eventually, the demarcation point between the customer and data center is actually this. This is the filter, 25 micrometer filter, which is going to decide if there are any issues with the rack, or if there are any like a metal parts. Is this coming from the primary loop up to the filter, which is responsibility from data center, or secondary loop, which is responsibility for the customer. Before the racks are going to arrive, you need to do a proper commissioning. So these 2 pictures are actually, this was the customer in Malaysia. So before the real racks have arrived, we use these load bank racks. Basically, this is like a rack which can simulate up to 200 kilowatt of capacity. And it's going to check all the pressure. So when we build a secondary loop, it's based on differential pressure. What that means is, it doesn't matter if you have 8 racks or 1 rack, as soon as you add additional racks, the pressure will be automatically adjusted within your secondary loop. And then, of course, the racks. So if you have an average air-cooled rack of, let's say, 25 kilowatt, this rack is approximately, let's say, 500 to 600 kilos. This rack is 1,600 kilo, and Vera Rubin, which is coming end of, let's say, Q3 this year, it's a 2,000 kilo. Going further, let's say if you have a normal 48U rack, 600 by 1200, that metal frame is good for 4,000 kilo. That's your maximum. The metal cannot hold more than 4,000 kilo. I hope that that is not going to come, but so these racks are right now up to 2,000 kilo. And then in order to push these racks, we are using these like what we call the server tag. So basically you need to push the rack to the final position. And right now, the current racks have 4 casters, the new racks will have 6, and if the rack is going above a certain limit, basically you will need like a small forklift to bring to a final location because the casters will not be able to hold the weight. Okay, so with regards to, talking about all these models and everything, what we have been seeing is, going from this perception AI, generative AI, agentic, and physical AI, the models are becoming more and more difficult, and basically that's the reason why we are trying to, let's say, get a better or more efficient, more dedicated chips in order to go and get this, to serve the customer and build these clusters. So compared to the, let's say, what happened last year is in the last, let's say, 2-3 months, we have seen that people have started using agentic AI, and then suddenly with OpenClaw and some other, let's say, capabilities, AI has started, or AI agents have started talking to the other AI agents, which means that you need even like a more tokens to produce in order to get this communication going on and for these applications. So as it was stated here, it's like low latency and large context required at scale. So this is just to show you, because the people are asking like, okay, you have started at 25 kilowatt, 45, you're going to 225, and some people are even talking, so the next year, 1 rack, 1 megawatt. So this is showing how, let's say, efficient these racks are. So you had with the Kepler, which was like K80, the first GPU, which was deployed in 2017, you had a rack of 42 kilowatt, and that rack was good for 1 token. So basically, like, if you say hi in ChatGPT, that is 1 rack of 42 kilowatt in 2016. Now with the Blackwell, which is GB200, and Blackwell Ultra GB300, you have like a 1 token for 0.2 joule, which is watt per second. So these racks are now capable of producing millions of tokens per second. This is actually what people are looking to use. So for the Vera Rubin, so in the beginning, or when we started, we had only GPU. Now that all these models are becoming more, let's say, more complex, it's not only GPU. How is the connections between, so like when we were in the beginning deploying all these clusters, your latency is like, we are trying to put as much as possible racks next to each other so that they can be connected, because every extra meter of cabling is 5 nanoseconds of latency. So because of that, we had also new spectrum switch, NVLink switch. I mean, you are seeing that this was a slide from 2 weeks ago. For the first time, we are also introducing Grok, which was purchased a few months ago. So in order to optimize the usage and creation of tokens, basically we have started now building additional chips and additional racks so that these AI factories can become even better in usability. So what we have seen, and then last year when we launched the Blackwell, then we got a couple of companies coming to us. And I said the first company was like Reliance in India, and they came to us and said, "Oh, we have a gigawatt capacity. Would you be able to give us a reference design for the data center campus?" That's when we started talking about this DSX, which is like so not only telling you how to build the AI factory from the hardware perspective, but also how do you build a data center which can bring all these racks together. And then also the models came a little bit, so we created this like a 5-layer cake. So like you have seen lately like a lot of people who are coming and saying, "Hey, I have a power and I have a space." So, and then in US we have seen lately like a lot of deployments where there is no grid. It's like just gas turbines or batteries. So the models are becoming a little bit different, but because of that, the layers and working with all these different companies, how do you build that is becoming a little bit more challenging. So we created this like 5-layer cake with energy, chips, infrastructure, AI models, and applications. And so when we started thinking about how to build a data center, the idea was, what do we do and how do we make everything to be as efficient as possible? So if you take like a gigawatt capacity, then we have seen like from a gigawatt grid power, what is the inefficiency in the power and cooling, what is the efficiency in the rack usage, and then, like when you need to restart and some reliability of the racks. So basically from a gigawatt, basically you can use like in most efficient way, like 60% of the power. So what do you need to do in order to get these stranded power to be used to go back into the system? And that's what we have started working on that and trying to see how we can help the data center owners, the customers with the power and land to optimize these AI factories. So let me just, so I need to start this video. Let me see. Yeah.
The greatest infrastructure build-out in history is underway. The world is racing to build chip, system, and AI factories, and every month of delay costs billions in lost revenues. AI factory revenues are equal to tokens per watt. So with power constraints, every unused watt is revenue lost. NVIDIA DSX is an omniverse digital twin blueprint for designing and operating AI factories for maximum token throughput, resilience, and energy efficiency. Developers connect through several APIs. DSX Sim for physical, electrical, thermal, and network simulation. DSX Exchange for AI factory operational data. DSX Flex for secure, dynamic power management between the grid. And DSX Max Q to dynamically maximize token throughput. It starts with SIM-ready assets from NVIDIA and equipment manufacturers, managed by PTC Windchill PLM. Then, model-based systems engineering is done in Dassault Systems 3D Experience. Jacobs brings the data into their custom Omniverse app to finalize design. It's tested with leading simulation tools, using Siemens Star CCM Plus for external thermals, Cadence Reality for internal, ETAP for electrical, and NVIDIA's network simulator, DSX Air, and virtually commissioned through Procore to ensure accelerated construction time. When the site goes live, the digital twin becomes the operator. AI agents work with DSX Max Q to dynamically orchestrate infrastructure. Phaedra's agent oversees cooling and electrical systems, sending signals to Max-Q, which continuously optimizes compute throughput and energy efficiency. Emerald AI agents interpret live grid demand and stress signals and adjust power dynamically. With DSX, NVIDIA and our ecosystem of partners are racing to build AI infrastructure around the world, ensuring extreme resiliency, efficiency, and throughput.
So as you see, we are trying to, let's say, work with the different partners with different parts of the data center ecosystem and trying to improve the efficiency. I'll just finish here with, this is what we announced for what is coming, let's say, next year, a year after that. So there are two things what I would say, like, because of the number of cables and you know, the racks are becoming bigger, the movement from 400 to 800 volts, so the 800 volt HDC is something which is coming in 27 and probably deployments to start in 28. And then because you are trying to build, so like when we started with air-cooled racks, you had a maximum one server, so your blast radius, so if the cluster goes down, the minimum what should work are 8 GPUs in one server. With a rack with 72 GPUs, if the cluster goes down, 72 GPUs will work. With the future technologies, we are expecting that these racks are going to grow 144 to 88, 576. We announced even 1152 GPUs in a single rack. I mean, probably that's not going to be one rack because 1152 GPUs is like 4 megawatt. So how to fit 4 megawatt in one rack? But in any case, bringing this all together and trying to improve and getting these millions of tokens is what is driving us to go and get this technology to get even better. So this is like a gigawatt design. We have just released 2 weeks ago design for 500 megawatt and 250. So if you need any help with that, please let me know. Thank you. I don't know if there are any questions or... Yes, please. So what we are saying for the... Also, the question was about the floor loading. So for these racks, which are, let's say, 1,600 kilo, 2,000, what we are saying, if you are building a data center, 5,000 kilo is the new floor loading. So probably like a concrete floor. Yes. That's true. So in that DSX design, so for example, now when we are talking with the data center providers, we are advising them to build the pods of average 4 megawatt, which means that right now you will be able to deploy 14 to 16 racks of 225. And then when the Vera Rubin comes, the 500 kilowatt rack, basically in, let's say, 3 years from now, you would remove 8 racks and deploy 8 of 500, or let's say you will be, maybe in like 5 years, you will be replacing that with 5 racks of 800 kilowatt. And then the secondary loop, so right now the previous racks were 1-inch hoses. The current racks are 2-inch. So what we are advising is that you put a 4-inch, and then from 4 you go to 2 for the current racks. Then when the racks are going to go out, you will remove 2-inch, and then you go with 4-inch straight to the rack. There are some documents, so if you delete the video which you recorded, I will share the documents with you.